time. So, but we have more time to wait for 300 years before acting. And the other idea is that we have to have a project. So we have to make, to have a vision on what may be the common future. So in fact, we have to also say what we value, what we share, what we value, what we care. And science is not designed by itself to discuss even philosophy in a way, maybe a little more, but to discuss what we care, what we share, what we value. And but we are in a time of a crisis, so we have to do that. We have to construct, to take a bet all together to construct a project for the future. So I will just show you. So I did art and science. I did many, I don't know, maybe 40 different installations. So one was shown in Voltare, two were shown in Voltare just yesterday. Here I show you one project, and I go from the scientific technique to the maybe the other layer, the artistic, and maybe the philosophic aspect. So the technique is this little video I will play again. So it's called, in fact, this is the core of the what is known as synthetic spiral or synthetic stereoscopy in science. So the idea is that you take a camera. So this is the raw image. There is aliasing because this is just a camera looking at the screen. But you take your raw background image. This background image should have a texture, but any kind. So it may be even a TV screen, and you look at the pixel. Then you have to make the focus extremely sharp on the background. So this is not something you do in photography usually, because in photography you use the depth of view as a technique, and you don't care so much if the object is in the middle of the field of view. But here, you have to fight with a very little signal, so you have to make very precise the adjustment. So we do that with a computer that will command the lens. You cannot do that with just trusting the automatic system of the camera. But then we have an image like that with the background, and the idea is very simple. And it's all about time, so it's all about perception of time. We have a very slow organ with the vision, because this vision goes to chemistry, the way we see. It goes to chemistry, so it's very slow. So we have no perception of very fast motion. We have perception of displacement of boundaries, so sharp, very, very sharp gradient. So your eyes is analyzing motion of very sharp gradient, but there is no perception of very small variation between two images. But let's imagine that there is the background, and there is maybe like an object of your own hand in front of the background somewhere. So the camera is over there, for example, the background is here, with a texture. You take the first image, and for example, half a second or 1/10 of a second after, you take another image, and you do the subtraction. So this is the image. This is the subtraction, and the subtraction you multiply that by a factor, multiplication factor, so a contrast factor. And in that case, you will see all the little motion due to the air, because if you have been watching Western, you know that when the cowboy is coming from far, you have a long length, and you look at the cowboy coming in the, usually this is the intro of the Western. You see all the thermal motion of the air in front of that. And here it's the same. There is thermal motion on top of my hand, and this thermal motion will, for the camera, it will modify. It will do an artificial Montelan displacement of the grid or the pattern behind, and if you do a subtraction, then you get the information. So this is this little movie. So this is the technique in science to study the dynamics of anything that happens in air or water. And you see here the thermal group of the hand. So if you move the hand, you will start in the air. This will be your print, or the fingerprint, what you leave behind when you move. You have the footprint, but you have also a print in there. And this print in the air is this effect. And so all this research is about, now I'm going to this series we just done with a workshop with 30 scientists and artists of all the generation. So half were graduate students, the other half were former graduate students like us. I'm sorry, those were here. And so this is a series of images just taken at random. So we did a little setting. So the little setting was, and the idea is that we want people to realize the microclimate. So the title is Microclimate of One, and one you may interpret that as the whole monad, a group of people, you may expand that. And the idea is to zoom on the microclimate in order to consider all the impact you have for a larger maybe impact you will have. So this is like a minimum impact. So the minimum interaction with the planet is you do nothing, you try to relax, you try to eat, so you do not have to think, because when you think you spend 100 watts, in particular when you listen to me, and then you have a thermodome above you, and so you may try to decrease your impact, but this will be the minimum impact, minimum interaction. And of course, our interaction is much larger than that. So it's just an idea, an artistic idea to use this technique. So it's something we do not perceive because we have not a visual system that allows this perception of very small change. We are not practicing, we have no access at this information just because our eyes, as I say, is a chemical device. So it's a slow chemical device. And you may do whatever you want in front of the camera. So this is images we set the installation for one afternoon, and this is random shot from what the people are doing with the installation. So people were entering, they were forced to screen to see what you do, where kind of behind you when you enter in the room. So when you enter in the room, you have to step into the field of view of the camera, and you have to start interacting with the microclimate of the room. So there is something that was very efficient because people were entering, then realizing they modify something, stepping out, and then they also we force the fact that they have to interact with the system. They cannot do anything if they are not in the room, and if they are not creating and modifying the climate of the room. So maybe this is all what we said today. So it's a food. So this is one example. There is many other research just to try to have installation that in a way not force, but propose another point of view, and then naturally we will consider many things. So it's a little like experimental thing. What I'm doing very often is a little experiment. It may be strange, but certainly you have to really, it's another connection, so it's strange because, for example, you never before maybe today saw you print like that. And when you have with the installation, it's also the first time you may visualize your own airprint. And just to say, to call that airprint, it's like a poetic idea because usually the fingerprint they will last for some time before somebody washes it. The airprint, it will last forever, but it will be diluted on the planet at some point. And then you have to reconsider what for you is a microclimate and what for you is one. And you may also, with the technique, you see that you may use also the technique to do other things with the motion you have done with your hand to create. So, for example, this image, the person must have moved quite a lot in between the two images in order to produce the more pattern in the image.
Hello everyone, my name is Ricardo Gonzalez. I'm a last semester computer engineering undergrad in the University of Los Angeles. And I started working in research last year with Professor John Guerra. He is a member of the Imagine Group. He gave me the opportunity to work with him and another student in his thesis. And yeah, the next semester I started working with Tiberio in this project, and now we have a new team member, Jose Felipe Quiroga. He is also a last semester computer engineering undergrad, and we are working in this project to complete our last project to wrap it. So first of all, let me start with the context of this project. Um, this funny guy um, he's always talking with many people from different backgrounds, and he started talking with the research unit in the Hospital Militar Central, and he had a previous project made with other students in this group called Ravis. And this project, basically, you can analyze radiography images and explore data samples of different patients to find interesting things and also visualize them quickly, like to empower doctors and researchers to find interesting things in studies made to patients. So Tiberio showed them this tool, and the military hospital research unit wanted to have these tools to teach their students. So he had the great idea to leverage a tool made by John Guerra. This tool is called Navio. Basically, it is a tool that it can be used to explore by different variables the information of a specific patient, and we can summarize all of the data of the data sample, so students and also possible researchers can find interesting things in the data of these patients and also prove some theories by exploring the different studies. So the project, summarized in one sentence, is creating a tool capable of creating data explorations, challenges for radiology students to learn concepts and gain practice in studying cases related to brain injuries and diseases. For now, this is the structure of the project. This is the architecture. We have three main components. The first one is it's like kind of like a server which contains all of the information of the patients, the radiography of the patients. Then we have our front end or front end. This contains the OR application, the data brain browser. And finally, we have, for now, Firebase to manage the accounts of the future students and doctors that will be using our application. Why are we using Firebase? Because uh, Firebase has all of the security and security features that are necessary to have a robust account management system, and we don't need to develop this part. Yeah, technologies, React and Firebase. Also, Firebase integrates very nicely with React, so that's also another reason to use Firebase. So, what functionalities will our system have? We will manage the users' accounts. This means creating the students' accounts, connecting, associating these accounts, like creating groups so doctors can manage their students and also send them assignments. Create the challenges. This means creating data samples. The doctors create data samples to assign to the students so they can explore the data and learn specific concepts that the doctor wants. Well, as I said before, assign the challenges. Integrate the Osiris web viewer. I will show this tool in the demo. This tool lets the students explore in greater depth the radiology scan frame by frame, so it's a much better way of analyzing the data of the patients. And finally, annotate patient studies. What does annotate mean in this context? It means adding text information and also calculating areas inside of the frames in the scan, MRI scan of the patients. So for now, we already developed a first approach of how the visualizations would look. Here we have many columns with interesting variables for the radiologists, like age, gender, diagnose, if the patient has a specific clinic study, what did they do to this patient to fix their problem, maybe they bled during their injury, and different variables that may be of interest for the students to explore. This is another important part that we already have. This is the challenge creation page, where we take the data samples, we take the different possible values of the available for each patient, and then we create a sample with specific constraints that the doctor determines. So let's say the doctor wants a sample with 3 people between the age of 10 and 20, 5 people that had a tumor in the frontal lobe, and I don't know, 30 female patients. So we take these inputs by the doctor, we filter through our data and we create a data sample. As you can see, we are missing the preview here. We want to add a preview so the doctor knows if he is creating what he actually wants. So this is what we have so far, and now we will show you a quick demo here. So as you can see, I think you can see more clearly here. Maybe let's search for female patients that had, let's say, a tumor, and maybe that they didn't have bleeding in their study. So here we can see a preview that lets the students see if they are actually interested in seeing this specific study, and if he actually wants to see in greater depth this study, then he can click the image, and this is the Osiris web viewer that I talked to you about before. You can see in greater depth the different studies of the patient, and then you can also use different angles, different functional scans, and all of that. We can also already annotate here, thanks to the tool development, the area of the frame we are seeing, and also have specific annotations like, I don't know, here we can see the tumor. So the person has a tumor here, I don't know. And this is the tool that will empower the students to look for interesting things in their exploration. So as you can see, this is what we have for now. And also we have this view, as I told you before. We can add a parameter, let's say gender. We have the possible values here, and we have the specific number of the patients we want to have with that constraint. So then we can add another one, and you understand the concept. So let's continue here. So in summary, the tool should be capable of, for doctors, accessing to the data visualization, creating challenges with data samples, with specific constraints, and also assigning and sending feedback to students to the submissions made to a specific challenge created by the doctor. And by contrast, students should also be able to access to these data visualizations, accessing to the specific challenges assigned by their respective doctor, professor, teacher, and finally submitting a response to the challenges with attached information. Attached information for now means text, images, and possibly the annotated image made by the student so that the doctor can review if he did a good job in the exploration of the patient's study. What we're missing right now is, as you saw before, the preview of the challenge when creating it, the backend logic to manage the challenge, the challenge's data and access to it, the backend logic to associate the students and the doctors, and finally, a user test with radiology students to prove that our tool is working properly.